So there are three different traversal mechanisms for a binary tree. Where note, let me just preface this that we're talking about binary tree. It does not only apply to binary search tree, but a general binary tree. So in other words, it does not have to be a binary tree where F and G, right? In this case, have values greater than D, and this subtree to the left of it having a value less than that. No, it does not have to be. So it could be anything. The binary tree storing any values inside, and this tree does not have to be balanced, meaning it does not have to have a the mirror plane right in the middle where if you fold the left to right, you get this symmetrical. No, it does not have to. Okay, it does not have to be a complete either. It could have any branches here. It could have branches here, here, right? It just keeps going. So the traversal mechanism applies to this type of binary tree. Okay, and later on, when we get to graph, this sort of traversal becomes a lot more complicated. But right now, this is assuming that each node can have up to 2 children. Okay, so there are 3 traversal mechanisms in binary tree. One is called pre-order. Second one is called in order, and the third one is called post order. Now, these are the 3 most popular traversal mechanisms, and all of these traversal mechanisms, these are depth first search. Okay, so this is D, F, T, depth first search or depth first traversal. And the reason is because we're not using any queue structures. We're not using stack either. This is simply, could be expressed in terms of a recursion. When we're talking about recursion, this is also expressible in terms of a while loop or for loop. So these are iterative methods. Okay, so let's kind of move forward with each of these. So pre-order means that we are interested in visiting the roots first. Okay, so this means root is B, right? In this case, so B, F, right? These are not nodes. These are inner nodes. These are not roots. In order traversal means that I want to visit my roots in between. Okay, right in the middle. So after I visited the left one, I want to visit the in, and then left, and then the right. So pre-order means that I want to visit my roots first, and then left, and then right. Okay, so it's root, left, and right. Okay, in that order. For pre-order, in order means I want to visit my root right in the middle, right? But I want to visit my left subtree first, and then right. Okay, so let me just preface this. The root is a root prime. Okay, root prime. R is the right, and the post order here is I want to visit my root at the end of my left and right. So you want to visit left, and then right, and then after that visit my low. So basically, I want my root prime, right? Root is prime. Sorry. So just in case, so this is root prime. So you can see here, root is D, right? D is being visited first, right? In the very beginning. So this corresponds to this guy right here. So I want to visit my root first. And in this case, my root is visited right in the middle after my left subtree has been traversed. And then before my right is traversed. So D is right in the middle, right? D is right here. And this other one is called post order. So post order means my root is visited last. So you see at the end of the very traversal that your root is visited last. And this D corresponds to R prime. Okay, so this is sort of the general binary tree traversal. Let's take a look at maybe some pseudocode to better understand this. And let me illustrate this with the real coding samples here in shortly. So this is the one way to kind of visualize binary tree traversal. Let me just explain what this is. So one is the traversal mechanism that generally visits the left side of the tree. Okay, left side of the tree. Now 2 means you're visiting root or inner nodes. That's kind of right in the middle, right? So this is R prime in my prior examples, R prime. So 2 is always like kind of the nodes that is kind of stuck right in between, and that's where we labeling 2 as. So 2 is right in the middle, and 3 in this case, right? 3 is my right, the traversal mechanism that goes up and right, go ups and down, right? But generally speaking, three, visiting the right is always recursing it back, right? So three direction for right is always in a reverse direction, going back to the root. Whereas one is the forward direction that leaves the root, and two is where you converge right into that node. So you can consider basically, if you look at this, all of the twos as the um, intermediary root, right? Because at this level B is root for right all of these subtree left and right. So this is kind of an illustration between, the directions where left subtree is labeled one, two is where it's, the recursion converges right in the middle. Three is where the information that or recursion that goes back towards the root directions. So this is a general binary tree traversal. This is not as important as just totally understand how pre-order, in-order, and post-order works. Let me just pick one. So in order in this case means that we are traversing left, right? And what is being read right in the middle is my root, and then the right side, right? So this is in that order, right? Okay, so you would expect that root, which is D here, being somewhere in the middle, which is exactly the case, right? So this D is sitting right in the middle. Let's take a look at the left side. So A, B, and C's are the left side, right? This is the left of that subtree D. So let me use a different color here. So basically, this entire branch here is the left side of that D, right? So D is right here. So left side of that is, and in terms of a traversal, because we're doing right left first, this means that the entire mechanism will recurse all the way into the D band of that left, which is A. And as soon as A is reached and there's no more, right? That's when you start printing stuff out, right? And that means A will be printed first. Now, after that is done, then the next step is right left and then towards the middle, right? And that's where this motion going back to right from A back to B, which converges right in the middle. Remember, B is the intermediary, right? Intermediary middle, right? Which is R1. So you have to think in terms of at any given level, what is that the predecessor, right? My tree, in this case, this side of the tree, the predecessor is B, and we know predecessor will be right in the middle. And this is the reason why after A, B is printed. And then obviously, because there is more note, right, more substrate emanating off of your right side of B, B, which is the right side, has to be read first, right, next, which is, this means that the traversal goes from A, B, and C, okay, A, B, and C. This is the reason why you see A, B, C, and then D, right, back to D, and then, yeah, so I would say it would be a lot easier if you follow the code and just trace the code, the recursive call where the flow controller is at any given point, to really, really, really understand this. Otherwise, I do not recommend that you memorize this. You kind of have to have a mental picture of where this thing is going to really appreciate this part. I would not, again, recommend that you just blindly, memorize this order. You have to kind of form visualization, and forming a visualization means you have to practice. Okay, so let me just move on to the next traversal here. And again, this is just another picture of the same here. And you should definitely go through in order, pre-order, post-order. But for brevity, let me just take the in order part, since this is the first one. And specifically the pseudocode that represent that in order. So I'm going to do this in Java. Let's just say this is a public void in order, and this in order takes the node. Node is our node structure that we have been demonstrating all along, right? And let's do this. So in the beginning, what you want to do, and the code is actually very, very simple. If node is not null, right? Or if null is null, what do you do? If null is null, there's nothing to traverse. So since this code returns nothing, you want to just return a flow control by saying return and be done with it. Otherwise, and since, like I said before, this is recursion. first of all, in order means that I'm going to traverse my node all the way to the left first. And then I wanted to basically print myself, right? So print myself is right in the middle, right? This is where you have print node, right? And this is the node value if we go back to what we had before. And then after the node that has been visited, right in the middle, if you want to do in order root, right? Okay, so let's take a look at this, and that's it. You can turn this into a recursive, not recursive, iterative fashion, but in order, right, to the left, and then visiting itself, and then in order to the right. Okay, so this means that I want to recurse all the way to the right, and then I want to print the middle, and then I want to recurse all the way to the right, all the way to the left, middle, and right. Okay, so this is kind of generally how an in-order traversal works in the abstract. So this might still be a little fuzzy. This is a little bit of a pseudocode and the actual Java code. Let me just clear this part and do the actual illustration. So now we're back to our demo. And this demo is going to be just like what we had before. And the first thing we need to do is to ensure that we have our node structures in place. I'm not going to write this out. This is the same as what we've been using from the very beginning. So this main class is going to invoke this node, and this node has its unique structure at left and right. And this is a typical tree node, okay? A binary node. And binary tree node. Okay, so let me just build our tree here. And before we do that, let me just say, going back what we have on the top, our root has a value of 15, and this one has a value of 10, and this one has a value of 20. Okay, again, this does not have to be, this is 10. This does not have to be a binary search tree, okay? But I'm just using these values at random. So you have a value of 8 here. Now, just to illustrate a traversal, I'm just gonna add another one. You know, again, this is not binary search tree, so the order doesn't matter. We can have a value of 2 here, okay? So this is 15, 10, 8, 2, 20, okay? Now, if you're gonna do an in order, this is what we would expect. We will traverse our left subtree first, and this left subtree has this. So what's going to happen is because we're going to recurse all the way through at the end, right? Let me just write this out, the corresponding code on the left side, and then we can kind of discuss what's going on here. Okay, so this is our bootstrap, right? Our main and then our node, and then the next thing we want to do is to make sure that we have a in order mechanisms in place. Now this static is going to call this static. So let me just set up another in order, and this one is a static void in order, and this one takes my nodes right from the outside. Okay, and the procedure is the code is it's very much the same, right? Checking to see if node is not null, right? If this is not null, then we can move forward with it, right? The other one is if node is null, then return. So it's the same idea. But what we want to do is we want to do it in order first, right? Node says I want to traverse my left first, and then what I want to do is to print out what I have, which is my node value, right? Plus, like I said, I want to print the whole thing out in a horizontal fashion. So I'm using this system out print, not print line. And in order, after done visiting my root or inner node, I wanted to print out my right side of that subtree with respect to that inner node. And this is basically done recursively, right? So you can turn this entire thing into an iterative code steps. But this should take care of what we have up there. But let's build our tree first before we get going. So our tree is node root equals new node, and this is our 15. So this establishes that 15 right there. So what I'm going to do is going to keep going, building my immediate left is got a new node of 10, and my new root to the right is going to have a node of 20, okay? And now my left, which is my 8 and 2, right, could be built with respect to the left equals new node, 8. Okay, so and this leaves us with my left right, which is new node 2. Okay, so this is how I built my tree and in memory. What I want to do is to traverse this particular binary tree, right, in order. So in order, my root. Okay, now let's take a look at what's going on here. If we, so this entire in order, right? No, like, first of all, the root is not null, so it can you'll take care of 24. So this in order is going to call it in order itself on the left. So it's going to keep going, right? And then going until what happens is node equal null, right? And that's where this part is, because there is no more to go, right? By default, right, left and right here is null. So after traversing node 8 recursively on its left, the flow control is going to reach a dead end, which is a null, which is good. This gives you the idea how deep, right, this level or height of the tree is, and also line 25 at its dead end, printing this value out. So what's going to happen is 8 is going to be printed. Okay, so that's that. And then as soon as 8 is printed, it goes into the right. But guess what? There is nothing here, right? There is nothing to the right of 8. This one is also null. So the entire flow control is going to go back and say, I'm done, right? So this level is done, right? And guess what happens is, and remember, how you would reach 8 means that 10 is going to be right in the middle, right? So the middle of 10 is going to be printed. So this means that flow control is going to go back to 8, back to 10. 10 is going to be printed, okay? And then after 10 is printed, is going to be 2, right? Because after visiting, right, after visiting the middle node, this part right there, which is actually going this way, will be printed. So the left, the entire right subtree will be printed as 2. And the same thing applies to, right, after you go back to 15, 15 is going to be printed, because now you're recursing your way back here. And 15, after 15 is printed, 20 is going to be printed. So we should expect the in-order to give us 8, 10, 2, 15, and 20. So let's just do a test here and make sure that we our code is written correctly to give us that. Okay, so the code does give us what we expect. This is the in order. Now, I would recommend that you practice doing the pre-order and post-order. All you need to do is to switch the order, right? So just remember, in order means that the root itself is going to be visited right in the middle. Pre-order means that your root will be visited first. Post-order means that it will be visited last. Okay, so this is just one illustration. In order to get really good at this, I would recommend that you practice it over and over again, and with respect to other traversal mechanisms.